challenge within a process unit is in a refinery, the density is always changing. And so converting that to a mass measurement for the mass balance tends to be very challenging. And so very often what happens is the instrumentation technician has to go out and check all of the measurements because the refinery, the process unit is not balancing. So you want it to be 100% and it might only be 94%. And so we go and we check all the calibration of all the instruments in the system, and they all seem to be fine, yet the material isn't balancing. So that is really the challenge, is getting accurate measurement, doing a test run, making sure that the process unit is in steady state, and collecting all the lab samples. So there's a big process involved in getting a good mass balance. Emerson's solution to help refiners to improve their mass balance is to really do an evaluation of all the different measurement points that contribute to the mass balance. And we can help to do that evaluation to calculate the uncertainty associated with different types of measurement, as well as a very particular installation. We can look at the installation, we can look at all the associated uncertainty that contributes to that measurement point, and that can really help to target very specific areas that need improvement. In one audit that we did, we examined the measurement point that was at the inlet to the crude unit. And that's not a custody transfer measurement, but it's a very key measurement point because it sets the throughput for the whole refinery. And what we found for that measurement, we basically did a gap analysis between what is the standard for measurement versus the current installation. And we found that the most significant thing that we found was related to the density, changes in the density measurement, which gave them an uncertainty of 3.5% on the crude input to the refinery. So being able to reduce that by putting in a live density measurement or installing a Coriolis meter was our recommendation for that refinery. By just installing a density measurement in a slipstream and having a live density measurement that would compensate their orifice plate, we could get down to 0.7% uncertainty. And then by installing a Coriolis meter, we could get down to 0.1% uncertainty. So the financial impact of that was huge.